Is it emergency? Go. All right. Next one, 4 parentheses 2 plus 3r minus 5r equals 73. Okay. So this is like what we did last week. Still integers, no fractions in the problem. What's the first step? Yeah, distribute the 4 that's in front of the parentheses to everything in parentheses. So that's 8 plus 12r minus 5r equals 73. Yeah, 12r minus 5r is the like term. So you got to put those together. 12 minus 5 is 7r. So next step. Subtract 8 from both sides. 7r, 73 minus 8, 65. Then what? Divide by 7. And reduce the fraction if it will. Does 7 go into 65 evenly? No. If it were 63, it would. But it's 65, so it doesn't go evenly. Is there anything that goes into 65 that also goes into 7? No. 7's a prime number, so it's only 1 and 7 that we can use. So we can't reduce it, but we can make it a mixed number. How many times does 7 go into 65, Ellie? By doing this division, when we're dividing by 7 here, 7 doesn't go into 65 evenly, so that we're going to leave it a fraction. Okay? You may have been told in the past to get the decimal. No, that's not what we're doing. Okay? Decimals are rounded values at some point, most of them are, and we want the fraction answer because it's the exact value.
So if we don't go into 65 evenly,
you can go ahead and divide it, yeah. If it will divide evenly, you go ahead and divide it and get that answer. Like if we had 24 on 1 and divided by 3, that goes evenly, and you just get 8. But here, because 65, 7 doesn't go into it evenly, you got to leave it a fraction and reduce it. That's how you know when to get a fraction. Okay. 9 and 2/7. 7 goes into 65 9 times. That's 63. Take away from 65 is 2/7. So there's the mixed number, 9 and 2/7. All right. -4, parentheses, 9 minus x plus 10x equals -48. So just throwing some negative signs in there. Still no fractions in the problem. Yeah, we're going to get the fractions in the problem. Right now we're just working on making sure we know how to solve a multi-step equation. First step. -4 times 9 and -4 times -x. So that'd be -36 plus 4x. 2 negatives multiplied together makes a positive. Plus 10x, -48. Yeah, combine the like terms. Next. That'd be 14x. And we still got the -36 on that side too. Yes, because the left side's got 2 pieces. We need it to have one that has a variable on it, so we need to move this 36. -48 plus 36. -12. Bless you. Last step, divide by 14, the number that's with the variable. There's x by itself. Does 14 go into 12 evenly? No. So we've got a fraction answer. Reduce it. Divide everybody by 2. 12 divided by 2 is 6. And 14 divided by 2 is 7. Negative 6/7. Do I need to make that a mixed number? Can I make it a mixed number? No, it's not improper. The number on top's got to be bigger for it to be a mixed number needed. Okay? Number on top's got to be bigger. All right? So I think we all got the process when there's no fractions involved. That's not a problem. Okay? Let's put some fractions in there and see what it does to the problem. It doesn't change the process at all. Well, I don't know if it necessarily makes it harder. If you know the rules for working with fractions, it doesn't make it harder. It does make it longer. I will say that, because if you got to add and subtract, you got to do the common denominator and all that stuff. But as far as, and sometimes that makes it harder. But Selena? Yeah, same process as example A was. We're distributing 6. Like, yeah, that's the next thing. If you're going to multiply a number times a fraction, usually it's easier if you got it as a fraction itself. And then over on the side somewhere, I'm doing some scratch work. I'm doing 6 over 1 times 19 over 6. How does that work? Yeah, cross cancel the 6's. 19 over 1, which is just 19, and that's nice. And then 6 times 2 is 12. So this is like, the intro to fractions. And, we started with a fraction in the problem, and it happened to work out where there's not one. That's always nice. Okay. Now what do we do? Minus 12. There we go. 19x is equal to 1. Divide by the 19. 1 over 19. That doesn't reduce 1. Anytime there's a 1 on the top, you don't have to do any reducing. It's done. No mixed number either. So, not bad for the first one with fraction in it, right? All right, let's do one that has a lot of fractions in it. -3 parentheses 5 over 4 x plus 6 over 5 close parentheses equals 11 over 20. It's very similar to example F. The only difference is it has fractions in there instead of regular integers, plain numbers. So what do we do first? Distributive property, the same thing. So we're multiplying -3 times 5 over 4. So that's a fraction and we're multiplying by. So I'm going to make that 3 over 1. -3 over 1, excuse me. So maybe somewhere on some scratch paper, I'm going -3 over 1 times 5 over 4. Can I cross cancel with that? So I go straight across. That'd be -15 over 4 x. And then over somewhere, I'm going to go -3 over 1 times 6 over 5. I can't cross cancel with that either, so that's going to be a -18 over 5. Because I'm doing what next? Okay, you said common denominator, but I got to do something to. So I got to add the 18 over 5 because it's a negative. To get rid of it, I'm going to add it. what would the common denominator for that one be? 20. 5 goes in 20. How many times? 4 times, right? You gotta do this. But when you're doing one, you gotta do another. Else you're gonna be even further. Because you're not gonna know how to do this. All right. So 20 is the common denominator. What times 5 gives me 20? 4. So top and bottom get multiplied by 4. So that's going to be 72. And then the 11 over 20 doesn't change, because it already had the right denominator. So I put those together. That's what? 83 over 20. Will that simplify any? 83 over 20? No. If it were 80 over 20, yeah, it would be nice. It'd be 4, but it's not. Okay. Multiply by the reciprocal, just like what we did Monday. These are gone. Yeah, we can cross cancel there with the 4 and the 20. Try again. 15 times 5. 5 times 10 is 50. 5 times 5 is 25. So that'd be 75. Is it positive or negative? Negative, because we multiplied by a negative 4 over 15. We cross canceled already, so we've already done the reducing. Now is there a mixed number that goes with this one? Yeah, top number's bigger, so that we know it needs to be a mixed number. Negative 1 and 8 over 75. Process is exactly the same. It's not changing. It's just the rules for adding and subtracting those numbers have to be followed. Okay. What are we on? F. Yeah. F. Let's do this. Negative 2. 11 over 3x plus 2 1/5 minus 6 5/6 x equals 10 3/5. Woo! Lots of fractions. Yes, ma'am. Absolutely. Mixed numbers got to be changed into improper fractions. That's the first step for any problem that has mixed numbers in it. So I'm not going to change anything else, even though I know some of the steps that should happen. What's 2 1/5 as an improper fraction? 11 over 5. And then 6 5/6. 36 and 5 would be 41 over 6. And that'd be 53 over 5. All right? Now what? Distribute. 2 over 1 times both of those fractions. Negative 2 over 1. So that's negative 22 over 3 and negative 22 over 5. Don't forget your x on the 22 over 3. This is a negative 2 times the positive makes that negative. If you wrote it plus negative, it's the same thing. But I just saved myself the pen stroke of the plus sign by writing the minus sign there. All right. Now what? Combine the like terms. We got like terms here with this one and this one. They're on the same side, so what do I do with the signs? I got to have a common denominator, and then do I change the sign of one of them? No. They're on the same side, so use the same sign. So I got to have a common denominator, which would be what? 6. So got to double this one. So that's negative 44 over 6x. And I got the 22 over 5, and then the minus 41 over 6x. So I'm writing an extra step in here. Then when I combine these two, negative 44 and negative 41 would be negative 85 over 6x. Now what? Add 22 over 5. This one's great because they already have the right denominator. So I don't have to do any work to get a common denominator. I just got to add those together. What's 22 and 53? 75 over 5. Is 75 divisible by 5?
Yeah.
Oh, well, I'm going to change that to a number then. How many times does 5 go into 75? 15. So that's really just 15 over here. And I got the negative 85 over 6 here. So I reduced right there. 75 over 5 would reduce. It happened to divide evenly. Doesn't matter if it divides evenly or not. If you can reduce that fraction, reduce it. That's what that'll save you a ton of work by reducing as you go. All right. Last step. Negative 6 over 85. That's the reciprocal. Put that 15 over 1. Can I cross cancel with this? All right. What's the biggest number that goes into 15 that goes into 85? 5. 5 goes into 15 3 times and into 85 17 times. So it'd be 3 times negative 6, negative 18, 1 times 17, 17. Well, that reduce. That's not reducing. That's making a mixed number. Doesn't reduce, but it becomes negative 1, 1/17. The process is not any different. It's all just a change in how you can add and subtract the numbers because they're fractions instead of integers. Okay, let's do one more. Let's flip the thing around. So it's 32 and a fourth equals negative 3 over 2x minus 5 parentheses 2x minus 1/4. So I'm gonna mix integers and fractions all together here, and try to put it all together and get x. First thing you should do: mixed number to improper. So we only got one mixed number to deal with. So that's 32 and a fourth. So that'd be 129 over 4. 32 times 4 is 128 plus 1 is 129. And then I'm Go ahead. I'm waiting on you guys. All right, so I like what you said, distribute a -5/1. So that sign goes with it. That's a common mistake, is to drop that sign when you distribute, but the negative goes with it. And, the first piece is -5/1 times 2. That's just -5 times 2. It's -10. And then -5/1 times -1/4. Which one? I heard two answers. I heard a -5/4 and a 5/4. +5/4. Because it's a negative times a negative. That's the reason. That's right. So I write plus 5/4. All right. All right, so I got like terms right here. 10 is 10/1. What would be the common denominator here? 2, so I'm on double. So that's really -3/2x minus 20/2x plus 5/4. When I combine these two, be -23/2x. And they already got the same denominator, so it saves me a little step there. Guys, if you can't choose where you sit and make it, I can choose where you sit. And you probably won't like it. So it'd be 124/4. And that can reduce, yeah. What goes into both of those? Good question. 6 won't go into 4. 4 goes into 24. So that's the divisibility rule. If the last two digits of the number are divisible by 4, then that whole number is divisible by 4. So 24 is divisible by 4. So 124 is divisible by 4. It goes 31 times. 4 goes into 12 3 times. 4 goes into itself once. Last step. Which is -2/23. There's x. Well, can we cross cancel with a 23 and a 31? Bless you. No, so we just got to multiply straight across. -62/23. Will that reduce? No, it wouldn't cross cancel, so it can't reduce. That's if it won't cross cancel at all, then it can't reduce. So that's the improper fraction style. Let's get the mixed number. 23 will go into 62. 2 times, that's 46. How much is 62 minus 46? 16. And guys, it's not because I'm a math teacher that I can do that math in my head. That's just number practice. Practicing adding, subtracting numbers. And to practice that more without just sitting at home and doing that is just don't touch a calculator when you're doing your math work. Or anytime you got to figure out something, try not to do it without a calculator. Try not to use a calculator and doing anything that you need to do. That makes you better if you do it correctly anyway. All right. So solving equations that involve some fractions, multi-step in this case. Tomorrow quiz will just have everything there. We'll have some equations that just have integers. We'll have some equations that have fractions and integers. We'll have some equations that just have fractions on that quiz. Okay? It'll cover the whole thing. Everything we've done the last 2 weeks will be on there.
Mr. Isbell?
Yes, ma'am.
I need J. Thieler rooted. Checking out, please.
All right.